Let's see. Is it recording? It is. Okay. So I'm going to try a different format today for this. So, if it works, it works. If it doesn't work, you guys can definitely let me know. So I'm going to start talking about section 1.3. I want to just make sure I kind of mention certain things like vector scalar multiplication. I think I might have mentioned it, but I just want to be sure. So what I mean by that is, say we have a vector v that's 3, negative 2. 2v would be 2 times that vector. So that 2v is going to be equivalent to 6, negative 4. So, just as a side, it literally means that vector v, which is 3, negative 2, is going to be half as much as 2, 3, 4, 5, 6. 2, 3, 4, boom. It's going to be half the, oops, wrong way. It's going to be half the magnitude, but the exact same direction, right? So that leads to the question, vectors, I've been trying to say are a direction and a magnitude. That magnitude could be velocity, could be acceleration, could be the length of the vector. But it can have different visual and sort of mathematical meanings. So one huge idea is the idea of, let's see if I got to figure some things out here yet. The idea of the unit vector. Let's see. I think I need, give me 1 second here. Basic tools, large, okay. Sorry, I'm still learning. So I'm going to do a new page here, and so this is a big one. Unit vectors. So a unit vector has a direction and a magnitude of 1. So the big thing is this has a magnitude of 1 unit, always. So we know that the vector 1/2 root 3 over 2, you might recognize those numbers from the unit circle. So I'll call this vector E. By the way, our textbook uses E to represent a unit vector pretty often. So the magnitude of this sucker, I don't want an equal sign there, humbug. So the magnitude of this E is going to be the square root of 1/2 squared plus root 3 over 2 squared, which is going to be 1/4 plus 3/4, and I think you can see the result is it's 4/4, which is 1. So that has a magnitude of 1 already. So I would say that E here is definitely a unit vector. But how do we construct a unit vector? How I think of a unit vector is this way. It's a direction with a meaningless magnitude. So the unit vector preserves the direction, but its magnitude is 1, which means we can scale it to be anything we want. So if we just have a direction, if we know a direction, we can just scale it. Do I want it 5 long? We can make it 5 long. So let's start with a classic vector. I'll call it vector P for Paulson. So this vector is 3, 4. It's a classic. Now the magnitude of said vector P is also a classic. Oops, that's not what I want. What am I doing? So that's going to be 3 squared plus 4 squared. So that's 16 plus 9, which you probably know is 25. So that magnitude, oh yeah, I forget I can do things like this. Ooh. Okay, so that magnitude of vector P, oh, come on now, buddy. Okay, so magnitude of P is going to be 5. So this is the thing that, at least in pre-calc, is really hard for me to convey to students. I don't know why the unit vector is so hard. It makes total sense to me, but whatever you need to do. So I'm going to say a unit vector E, that's what our book uses, and I'm going to put a little p down here because it's going to be in the direction of P. So I can construct that unit vector by taking the original vector P and dividing by its magnitude. Now let me show you what I mean. That really means we're going to multiply by 1 over its magnitude. So what I mean by that is the unit vector E that's in the direction of P, if I multiply that vector by 1/5, right? So this is vector P, and this is the magnitude of vector P. So if I do that, let's see here, that's going to give me 3/5 and 4/5, which is still, so all I've done is multiply by a scalar, because multiplying by a scalar does not change the direction. It only changes the magnitude. And so if we want to check out the magnitude of this vector E in the direction of P, in case you didn't believe me, which is fine, you should be skeptics. All students should be skeptics. Prove it to me, Mr. Paulson. I don't believe you. Oh, all right. That's my burden that I bear, and it should be. Okay. Let's see, and there we have something else again, 9 plus 16. Oh, it's 25. Oh, gosh. So that's 25 over 25. So it's 1. So this is sort of the golden, it's not the golden rule. This is the rule right here for a unit vector. We'll see if there's any questions about that. Hopefully it's still a little bit of a review. So yeah, so I'll just add again that this vector here has the same direction as vector P, but it's only 1 unit long. So that's good. Okay, let's see. What next should I add here? Maybe I should pause there and see how this adds up. I'm going to stop recording there, and then I will start another one. So.